Imagine for a moment that the sky has a doorway, not a metaphorical one, but a real physical portal where the slow drift of interstellar time brushes our own. Tonight, that doorway is the pale arc where our star hides a traveler, Comet 3IA TLAS. A true interstellar visitor, not born in the sun's cradle, but in the cold outskirts of another star's debris, now sweeping around our system, and beginning the long outward leg home. It has just passed perihelion, its closest distance to the sun, skimming past at roughly 1 1/3 Earth. Sun distances, which in plain words is about 126 million miles or 203 million kilometers. That number isn't poetry. It's geometry inscribed by gravity, the same gravity that bends planets into years and comets into long ellipses and hyperbolas. The international observing community pegs this close past to October 29 to 30 with spacecraft and solar observatories watching through the sun's glare, while earthbound telescopes blinked and waited for the comet to emerge again. You can think of perihelion like threading a cosmic needle. A comet falling in from deep space converts its fall into speed, then swings around the star and heads out again, carrying away a little of the sun's heat in the faint blue-green of its gases and the ash-grey of its dust. With 3IA TLAS, that threading happened while the comet sat almost directly behind the sun, from our point of view, an alignment called solar conjunction. That's why you didn't see it blaze across the morning sky. The sun was in the way. But spacecraft near the sun and images designed to stare into that fierce brightness have been on watch catching the comet's glow, even as it disappeared from ordinary eyes. Expect it to creep back into view before sunrise in November and improve in placement into December, though it will remain a challenge in modest amateur instruments. This is only the third time we've caught such a thing, a small body from another star system inside our astronomical village. First came 1I Oumuamua in 2017, a shard that never grew a tail. Then 2I Borisov in 2019, a more classical comet that shed gas and dust. And now 3IATLAS, discovered by the Asteroid Terrestrial Impact Last Alert System, Atlas at the Chilean station on July 1, 2025, with follow-up characterization led by an international team, including Michigan State University's Darrell Seligman. The early technical reports laid out the essentials: a hyperbolic trajectory, the mathematical signature of an interstellar path, and a growing coma that signaled genuine cometary activity. You can almost hear the relief in those data after the puzzles of Oumuamua here. Finally was an interstellar traveler that behaved like a comet again, venting ices under sunlight's steady pressure. What does interstellar really mean here? In math, you'd say the orbit has an eccentricity slightly above one picture, a stretched ellipse that never closes on itself, a path that dives in once and never returns. In plain language, the comet is not a citizen of the sun. It's a visitor passing through. The physics is simple and beautiful. Gravity pulls, momentum carries sunlight, warms ices, sublimate gas, drags dust outward, and a tail blooms in the direction away from the sunday. When the comet is close, the heating goes as 1 over distance squared, which is to say that halving the distance quadruples the power absorbed. That's why the moment of perihelion matters. It's the stress test, the thermal crucible in which fragile crusts can crack, jets can roar, and sometimes nuclei fragment into smaller shards. And 3IATLAS appears to have passed that crucible in style. Space-based eyes recorded that it brightened rapidly as it swooped behind the sun, the telltale sign of vigorous outgassing and sunlight driving fresh jets off its surface. There are images of a prominent jet shooting sunward, a narrow lance of material accelerated by evaporating volatiles, carbon monoxide, carbon dioxide, water, the usual suspects in a cometary mix, but in this case screaming confirmation that the object is active and crucially natural. More than that, ultraviolet observations from NASA's Swift telescope detected the faint glow of hydroxyl, the hydroxide ion, OH, a daughter product of water vapor split by sunlight, essentially a chemical fingerprint that says yes there. Is water here, streaming off a nucleus older than Earth itself? For an interstellar object, that's a profound clue. It says that the recipes for icy bodies around other stars include the same simple molecule that drenches our planet and underwrites our biology. Let's place this traveler in space and time. At perihelion 3, IATLAS was roughly 1.36 astronomical units from the Sun outside Earth's orbit inside Mars's, moving so fast that numbers begin to lose their human scale. From our planet, its minimum distance won't be close at all by Comet Watcher standards, about 1.8 astronomical units on the order of 170 million miles in mid-December. So there's no hazard here, only an opportunity for patient observation and brightness. Expectations are that it will peak around magnitude 11 to 12, far, far dimmer than naked eye, which means astrophotographers, small professional telescopes, and clever amateurs with larger apertures will do most of the seeing for us. That may feel like a letdown if you're hoping for a great public sky show, but it's a gift to science. A clean interstellar sample, slow spinning, past a swarm of instruments capable of teasing out composition and structure. What can we learn from an interstellar comet's breath? For one thing, the ratios of gases and dust. Do we see more gas than dust? A relatively blue coma that hints at molecules glowing in sunlight, or a redder fog saturated with tiny rock fragments. For another, the specific fingerprints, carbon monoxide, humming at very low temperatures, carbon dioxide, flagging subsurface layers and water always telling us about the thermal history. Swift's OH detection is especially evocative because hydroxyl is like the echo of water in ultraviolet light. You don't always catch water directly, but you see its daughter molecule and know the parent is there. That's how astronomers often track water around comets without needing to bottle the vapor. And when different instruments agree, when solar coronagraphs, heliophysics, imagers and ultraviolet telescopes all sketch the same story, confidence climbs. There's also the question of size. Early analyses suggest a nucleus spanning several kilometers across large by interstellar object standards, and if confirmed, making 3IAT LAS the heftiest interstellar visitor we've yet measured. Why does that matter? Because size sets the stakes in the thermal game. A larger nucleus has more thermal inertia, it warms more slowly, cools more slowly, and tends to survive perihelion passages that would shred a smaller, fluffier body. Surviving intact means we can follow its behavior for months, watching the outgassing fade as sunlight slips away and the comet drifts back into interstellar darkness, its trajectory only slightly altered by the sun's pull. If you could ride alongside, what would you see? Imagine a charcoal dark iceberg spattered with ices that formed under a different star's early glare, its surface stitched with fissures where solar heat drives jets. Those jets carve gullies, loft talc-fine dust that paints the coma, and sometimes fan into an anti-tail, a perspective trick where dust lingers along the orbital path and seems to point toward the Sunday. As the nucleus rolls, jets switch on and off, steering subtly like thrusters. It's not magic, it's momentum. But to the eye, it looks alive like breath in winter air. We picture the tail as a banner, but it's really a windsock. It points with the solar wind, not with the comet's motion, and it can kink and tear where magnetic fields pinch the flow. Those kinks are not decoration, they're physics made visible. The deeper gift of 3IATLAS is comparative planetology. With each interstellar traveler, we can ask, do other planetary systems make comets like ours? Are their kitchens stocked with the same molecules? Swift's OH glow argues yes for water. The colour trends argue for a gas-dominated coma right now, which may shift as the dust gets lofted more efficiently on the outbound leg. If you love the oldest stories, you'll hear a resonance comets, whether local or interstellar, are archives. They carry records of temperature, chemistry, and collisions from the first instance of planet building. The more samples we see, the better we can map what's universal in planet formation and what's idiosyncratic, the fingerprints of another sun's nursery lingering in a few spare molecules of vapor drifting off a rock ice kernel. And there is that other kind of gift, less technical and more human. We are watching a messenger we did not summon from a place we cannot yet name, swing around our star under laws we do understand. The certainty of the physics frames the mystery of the origin. Teams led by observers across the world, professionals and amateurs alike, are stitching together light curves and spectra, teasing out rotation rates, hunting for hints of breakup and coordinating windows as Earth rotates. And the comet rises, earlier each morning. In the first weeks of July, they watched it brighten through magnitude 17 into 16, and better then slip into the sun's proximity and vanish from common sight. And now they'll catch it again in dawn's electric blue. The cadence feels like a breath, in, out, a single inhalation across 30 light hours of space. Because 3IATLAS is interstellar, there is a temptation to leap to fantasies, spacecraft artifacts, deliberate messengers. Science is a steadier light. The published discovery analysis emphasizes the natural cometary behavior and the hyperbolic orbit consistent with an unbound visitor. Subsequent spacecraft images showing jets and the ultraviolet signature of water strengthen that conclusion. If an object looks like a comet, outgasses like a comet, and obeys gravity like a comet, the cleanest explanation is that it's a comet. That doesn't dim the wonder, it grounds it. A natural interstellar comet is a relic. You can test a hypothesis, you can refine a little piece of elsewhere, offering itself to our instruments. What should you look for practically as it reappears? We're chasing delicacy, not spectacle. A dim, diffuse glow before dawn, low in the east at first, then climbing modestly as November unwinds into December. If you're in dark skies and have access to a mid-sized telescope, or can piggyback on an online network of robotic scopes, you may catch its soft core and short fan of tail. Astrophotographers will do the heavy lifting, combining minutes of exposures, stacking frames, subtracting the star field, so the comet's motion snaps into a single sharp smear of light. Professionals will chase spectra, looking for subtle changes in bands that mark water products, CO and CO2 sodium, maybe nickel, testing how sunlight wakes different layers in the nucleus. Expect the comet to fade as it recedes, because distance dims both the sun's heating and the brightness that reaches us, each falling off with the square of distance. It's the same simple rule your intuition already knows. A campfire twice as far away looks 4 times dimmer. A comet twice as far is harder to see and easier to ignore. But don't ignore this one. The next interstellar comet may be brighter or closer or stranger. The universe is generous with surprises, yet 3, IATLAS, is here now, writing a thin luminous line into the archives of 2025. To stand under a sky that contains a rock from another star is to feel the Milky Way shrink and expand at once shrink, because the laws are the same there and here. Expand because the stories are different, the starting conditions shifted, the exact music of chemistry composed in another key. So step out before sunrise in a few weeks, when the glare has passed and the comet lifts from the sun's edge. Let the city quiet, let dawn pulse, and if you can't see it with your eyes, know that it is there, that cameras are catching it, that spectra are wringing meaning from its breath. We live in a time when interstellar visitors can be named, measured, and understood, and that is not ordinary. It is extraordinary in the way the best science is extraordinary, patient, precise, and open to wonder. And somewhere far beyond the heliopause, in 100,000 years, a different sky will claim this same pebble of ice and rock and call it local. For a blink, it is ours to learn from. Then it goes on. Key facts at a glance for orientation in the night sky, and the mind's eye perihelion late October at about 1.36 AU from the Sun. Reappearance for Earth, base telescopes likely in November dawns. No close pass by Earth. The minimum distance is around 1.8 AU in December, far beyond any hazard. Water-related OH glow detected by SWIFT, supporting active natural comet chemistry. Rapid brightening and jets recorded by solar watching spacecraft as it slipped behind the Sunday. Every one of those facts is a thread, and when you weave them together, you get a single shimmering truth. An interstellar comet came to our star, survived the heat, and is now receding, blue-tinted, whispering its inventory of alien ices into our instruments as it goes. Let's pick up the thread from the moment 3 IATLAS curved around the Sun and began to climb the long, cold ramp outward. Perihelion is over. The furnace test is done. The numbers are steady and specific. The comet skimmed past at about 1.3 to 1.4 astronomical units, which simply means a little farther from the Sun than Earth, is around 130 million miles, give or take a few million, depending on which ephemeris you read. The timing was late October, with several teams converging on the same window. Universe Today summarized it as around 11:47 Universal Time on October 29, and NASA's overview put the closest approach distance near 1.4 AU. If you like mental pictures, imagine a racetrack where Earth runs lane 1 and the comet briefly cut across lane 2 and kept going, not bound to the oval, but to a graceful open curve that never closes. We know this because the orbit's shape is hyperbolic, slightly more than an open ellipse, which is the mathematical way of saying visitor, not resident. Because perihelion happened with the comet almost exactly behind the Sun from Earth, no ground-based telescope could stare straight at it in that moment. That's not a mystery, it's celestial geometry. But spacecraft had front row seats. Keith Cooper's report notes that while our telescopes blinked in the daytime glare, Heliophysics images and observatories nearer to the Sun were watching for the characteristic surge in activity, the rousing of jets, the swelling coma, tail knotted by solar wind. The expectation, which is already being borne out, was that 3IA TLAS would be most active near this turn, and then as it recedes would ease back to a quieter state. It will only creep back into pre-dawn skies, for Earth observers later in November into early December low, and delicate more a prize for careful astrophotography than a naked eye spectacle. We should be patient here. The physics has a pace of its own. One of the most exciting early results landed not during perihelion but months earlier, and it answers a simple, profound question. Does this interstellar visitor carry water that can be detected from here? NASA's SWIFT, ultraviolet divided by optical telescope, picked up a faint ultraviolet glow from hydroxyl OH, which is a telltale daughter product of water vapor split by sunlight. In plain terms, sunlight knocks water molecules apart, and one of the fragments glows in ultraviolet. Catch that glow, and you've heard the water without seeing it directly. BBC Sky at Night magazine summarized the detection, showing visible light and ultraviolet views side by side. The interstellar comet is indeed breathing water into space. That matters because it says that the icing recipes in another star's nursery included the same simple molecule that floods our oceans and threads biology together here. It turns interstellar poetry into a laboratory measurement. The European Space Agency added an almost cinematic vantage point in early October when its ExoMars Trace Gas Orbiter and Mars Express looked outward from Mars and caught the comet gliding by from about 30 million kilometers away. Those cameras were built to stare at bright red rock just below them, so nobody expected dramatic portraits of a faint comet in deep sky. Yet they still caught the puff of activity, an interstellar interloper angling past another world. That was the closest view any ESA spacecraft could get, and it came at precisely the moment Earth was shut out by the sun's glare. It's a neat reminder that planetary exploration hardware can sometimes double as comet watchers, especially when geometry gives them the angle we lack. If you're collecting waypoints, here's the one you can circle for peace of mind. The comet will not come close to Earth, not even astronomer close. The best current estimates place the minimum distance at around 1.8 astronomical units, roughly 167 to 170 million miles in December, which is far beyond any hazard, and frankly not great for brightness either. That's why you keep seeing the same sober guidance echoed. This is a science target, not a public light show. Expect peak apparent brightness around magnitude 11, or a bit fainter. That's about 1,000 times dimmer than the faintest stars you see from the city, and still several dozen times dimmer than what dark-adapted eyes can manage. So, no panic, and also no headlines about a green broom in the sky blazing over your roof at midnight. We're in the regime of careful measurements and long exposures, and yet for images there is real beauty here. As the comet swung sunward, spacecraft and coronagraphs caught a narrow jet pointed roughly toward the sun, a classic behavior where heat turns buried ices straight into gas. The gas drags dust, and the outflow carves a bright lance in the comet. Coma. Space.com highlighted the jet images and emphasized the timing near the time activity should crest just as the comet was too close to the sun for ground telescopes to compete. When you combine those pictures with Swift's OH detection, you get a coherent narrative, a natural nucleus venting, volatiles, a coma rich in gas, and a tail shaped by radiation and the solar wind. We like this because it's consistent, because different instruments, different wavelengths, different vantage points all hum the same tune. Discovery stories matter too. Atlas, the asteroid terrestrial impact last alert system, flagged the object from its Chilean station on July 1, 2025, and almost instantly the broader community started pulling old images to find recoveries that extend the arc backward in time. Reuters and The Guardian both did strong early explainers, third interstellar visitor after Oumuamua and Borisov, a hyperbolic path, no risk to Earth, and likely a larger nucleus than Borisov. Michigan State University then amplified the scientific response in an early first paper note, pointing to how quickly teams mobilized to get spectra and photometry before the conjunction shut Earth out. This is how modern astronomy works. At its best, survey flags, community rallies, specialists carve at the same block of marble from different angles. There's been a swirl of speculation, of course, some think pieces tossing out ideas about artificial origin, motherships, probes. It's part of the cultural weather now whenever we meet something interstellar. But science gives you a sturdier umbrella. The observations we have are exactly what you would expect from an active comet nucleus coma growth with decreasing solar distance. Jets modulated by rotation, water, product lines in the ultraviolet, photometric behavior that tracks standard cometary brightening, and now a gentle fade expected as the geometry worsens and the heating drops with the square of distance. That last point is key. Double the Sun-comet distance, and both energy input and observed brightness fall by a factor of 4. It isn't a mystery, it's how light spreads, and your intuition already knows it because a campfire looks 4 times dimmer when you're twice as far away. Extraordinary claims need extraordinary evidence. Right now, the ordinary beautiful comet explanation fits the data snugly. What will the next few weeks bring for observers? First, reappearance low in the eastern pre-dawn, the comet crawling out from the sun's glow. Space.com's guidance and Universe Today's timeline both suggest late November into early December for workable dawn geometry. Second, a competition between distance, which dims the comet, and dust physics, which can sometimes keep the tail photogenic for a while as grains continue to scatter sunlight. Expect astrophotographers to stack many minutes of tracking exposures align on the comet's motion to keep it sharp while the stars trail, and then tease out a fan-shaped dust tail and perhaps a fainter, straighter ion tail pointing almost directly away from the sunday. If activity remains gas-rich, filters centered on specific emission bands, like the familiar cyan glow from diatomic carbon, may snap the contrast a little. But keep expectations modest. This isn't a stadium show, it's chamber music at dawn. Meanwhile, scientists will do what they do best: measure. There are a dozen quiet questions to answer. How does the gas-to-dust ratio change as 3 IAT-LAS cools? Are there hints of unusual volatiles, extra carbon monoxide at low temperatures that tell us something about where this nucleus accreted in its home disk do? Rotation light curves betray a lopsided shape, or even a contact binary? Did the perihelion heat stress open new vents, which we might infer from a subtle shift in colour or a kink in the tail where fresh dust was dumped? And can we reconcile size estimates? Some early press pieces hinted at very large, up to tens of kilometres, but the community tends to converge toward a few kilometres once the coma's contribution is modelled carefully. Expect iterative refinements here as modelling peels coma light away from any direct nucleus signal. We should be content with ambiguity for a while. It's how science breathes. If you're imagining how to visualize this for a showpiece screen, the way the Las Vegas sphere wraps an image around your whole field of view, lean into the truth the data gives you. Start in ultraviolet paint, a corona of faint sapphire around a charcoal kernel, label it OH glow, and let that ring pulse with the cadence of Swift's detections. Crossfade to the Mars view, 2 tiny spacecraft icons perched above a rust-red crescent, the comet, a soft blur beyond, and the distance marker ticking 30 million kilometers. Then plunge to the inner heliosphere, draw a stylized sun flare arcs curling, and thread a thin violet jet pointing sunward from the comet as it slides through the glare. Finally, widen to a planetarium dome plot, Earth and the comet on opposite sides of the sun, at the late October. Turn, then let the comet's path draw outward in a slow spiral of dots. Each dot, one dawn, closer to December, one dawn, closer to that 160-something million mile minimum distance. It's cinematic, yes, but it's also faithful to the best current ephemerides and reports. And because you asked for the science to be plain where there's any math, let's translate the 2 most important proportionalities. First, sunlight falls off as the square of distance. If the comet is twice as far from the sun, each square meter of its surface gets a quarter of the energy it got before. That tends to slow the outgassing. Second, brightness you see from Earth also falls off roughly as the square of your distance to the comet, all else equal. Double your distance, quarter the brightness. Stack those 2 together on the outbound leg and you get a double dimming, less heating, and a farther target. That's why the law of comet watching often celebrates inbound approaches, and why outbound comets fade even when they still carry a great deal of dust. No equations necessary, just twice as far, 4 times less in 2 different ways that multiply together. There's something quietly historic about how ordinary this is beginning to feel. Oumuamua startled us in 2017. Borisov, 2 years later, reassured us that interstellar objects can look like regular comets. Now 3 IAT-LAS is giving us water, fingerprints, jets, and a geometry that invited Mars-orbiting cameras to participate when Earth could not. The pipeline from discovery to multi-platform observation to public synthesis is smoother, faster, calmer. It's as if the cosmos is becoming conversational with us. This is how often you should expect a visitor. This is how we behave. This is how to catch us in the sunlight and the dark. We are getting good at this, which is not the same as getting bored. It's a different kind of wonder, the practiced wonder of a craftsperson who knows their tools and trusts the grain of the wood. So yes, the short-term plan is human-size, pre-dawn, November watch list, a December minimum distance that is safe and unshowy spectra, that fish for faint lines in the violet and near-infrared light curves that hunt for a wobble. The longer-term plan is cosmic, to fold 3 IATLAS into a comparative catalogue of interstellar small bodies, to ask which chemistries repeat, which spin rates recur, which colours mark deep frozen birthplaces, and which outliers hint at disks that formed under different stellar lamps. Each detection, like Swift's OH band, is a syllable. Each jet is a punctuation mark. Each tail kink is an accent in the sentence. Together they say the recipe for worlds is shared, but the kitchen is large. If you step outside before sunrise in a few weeks and the horizon is clear, hold the image in your mind, even if your eyes don't catch the glow. Think of a cold, dark core, a few kilometers across, bandaged in ice, that formed around another star, now falling quiet as the heat slips away. Think of a thin gas, water, carbon dioxide, carbon monoxide, rustling off that surface and being peeled into a tail by sunlight and the solar wind. Think of Mars orbiters turning their cameras outward for a once-only view when Earth couldn't look. Think of ultraviolet photons, shattered from water, re-radiated as a whisper blue signature that crossed millions of miles to a small telescope called Swift. We stand here on one world inside one sky, and still we can listen to a snowball from another sun as it talks about its home. That is the scale of 2025 astronomy. That is the scale of our curiosity. And that, more than any headline, is why this dim traveller matters. Imagine standing in the early blue of pre-dawn and trying to picture something you can't yet see. A cold, dark shard from another sun, fresh from the furnace, and now drifting outward, cooling breath by breath. That is where 3 IATLAS is tonight, past perihelion, the moment of closest swing around our star, and easing onto its long outbound leg. The timing and distance are not guesses. Multiple ephemerides converge on a closest approach to the Sun near October 29 to 30 at roughly 1.35 to 1.4. Astronomical units about 125 to 130 million miles comfortably outside Earth's orbit, and still far inside Mars's lane. In plain terms, it dove in, never crossed our path, and is already on its way out. Space. Comms observing brief sets perihelion at 1.35 AU, and underlines why the moment went unseen from Earth. 3 IATLAS was tucked behind the Sun from our viewpoint, lost in the glare, until it emerges into the dawn sky, later in November. NASA's overview says the same thing in institutional prose perihelion about October 30, distance about 1.4 AU. The numbers sing the same tune, which is what you want when the sky is bright and the object is faint. What happened in that hidden turn matters, because comets are heat engines powered by sunlight. Warmth wakes ices. Ices erupt as gas. Gas drags dust. A coma grows and tails stretch. When you double the Sun-comet distance, the energy falling on each square meter drops to a quarter. That's the 1/distance squared rule you feel every time you step away from a campfire. Around perihelion, the reverse happened. The last few percent of inward fall gave 3 IATLAS a steep ramp of heating, so it was primed to be most active precisely when we couldn't look straight at it. We had to let spacecraft take our place. Heliophysics imagers and far-flung probes had the geometry we lacked, and investigators were ready because they already knew this visitor was lively. A month earlier, the Gemini South telescope in Chile, operated by NSF's NOI lab, caught the comet's growing tail and brightening coma as it fell sunward. A simple, beautiful confirmation that this interstellar traveller behaves like a real comet when warmed. Then came the chemistry, faint, ultraviolet, and deeply consequential. In July and August, long before the glare shut Earth out, NASA's Neil Gehrels Swift Observatory detected the ghostly ultraviolet glow of hydroxyl, OH, around 3 IATLAS. That glow is a daughter signal from water molecules broken by sunlight, CO, and you've almost certainly got water vapour feeding the coma. The BBC Sky at Night team summarised it crisply. Swift's UV view picked out OH at a distance where ordinary comets are often still quiet, implying either very effective release of small icy grains that can heat, sublimate quickly, or unusually efficient water activity for an interstellar nucleus. In plain language, a telescope above the atmosphere heard water whispering from another star's leftover snowball. It is not philosophy, it is a spectrum. Geometry added a lovely twist. In early October, as Earth's eyes were beginning to squint into the sun, Mars had the better angle. ESA reports that its ExoMars Trace Gas Orbiter and Mars Express turned their cameras away from the brightly lit planet below and with long exposures coaxed the comet's fuzzy core plus coma from the black. The nucleus was far too small and far too distant to resolve, but the halo, a few thousand kilometers wide, was there a tangible blur from 30 million kilometers away in the Martian sky. Those frames do double duty, they document activity and they prove how a planetary fleet can improvise. When Earth had the worst seat in the house, Mars looked outward and kept the thread. What then does 3 IAT LAS tell us as it cools? First, that water is on the menu. Swift's OH detection is a clean, repeatable clue, and that makes this object rhyme with comets forged around our own Sunday. Second, that we should expect a compositional story that changes with temperature. Space.com's perihelion briefing points to early signs of a richer than usual carbon dioxide contribution, and even a higher abundance of nickel lines than many solar system comets show, with iron lagging in the current. Spectra. If those hints hold up under more data, they become a kind of chemical accent, a way to say this one grew up in a cold pantry with a slightly different recipe. Hubble images taken pre-perihelion show classic dust behavior and a sunward jet, while the halo's color trends blue when gas dominates and redder when dust takes over. Another lever scientists can pull to read composition as the comet glides from hot and loud to cooling and quiet. We read these changes like weather, because they are weather on an airless world, sunlight as wind, sublimation as surf dust as spray. About distance and danger, it's all comfortingly dull in the scientific sense of reassuring. The best current solutions put the minimum distance from Earth near 1.8 astronomical units in mid-December, around 170 million miles, so there is no hazard to talk about, only logistics for observers. Universe Today notes perihelion at about 11:47 on October 29, and underlines what your eyes will soon tell you: reappearance in the morning sky, late in November, low and delicate. NASA's public guidance mirrors the faint target expectation and keeps the distances straight. If you're thinking in magnitudes, the consensus hovers near 11 to 12, at best far too dim for naked eyes, often challenging even for small backyard scopes. This is a target for careful astrophotography, for long-stacked exposures, for filters that pick out specific emission bands, and for big professional mirrors with time to spare. In an age that loves spectacles, this is chamber music. But in that quiet is an extraordinary comparative experiment. We now have 3 data points: Oumuamua, which was maddeningly dry in the optical sense and never grew a visible coma; Borisov, a classic gas-rich comet that looked at home the moment the sun touched it; and Atlas, which is plainly active and carries water signatures at larger distances than many of our local comets. Michigan State University's running dispatches make the stakes explicit. With each interstellar object, we stitch together a map of how other planetary nurseries stock their ice shelves. Some early press called Atlas very large, but Hubble-based estimates summarized in a preprint trend toward a nucleus, only a few kilometers across, big enough to carry thermal inertia, and survive perihelion small enough that jets can torque its spin and sculpt its coma. That kind of size also squares with why the comet will never be bright to the eye at our distances. Brightness is not just how much stuff you carry, it's also how far you are and how efficiently you turn sunlight into glow. Double the distance and you quarter the light you receive. Double the distance from the sun and you also quarter the heating that drives the activity. Outbound comets dim twice over less fuel burned and the lantern farther away. If you want to imagine the physics cleanly, hold 2 pictures in your head. The first is a windsock, that's the ion tail, pointing almost directly away from the sun because charged particles in the solar wind pull it taut. The second is a trail of dust sprinkled along a path, that's the dust tail, and under the right geometry, an anti-tail that seems to point sunward because we're looking along the sheet of dust in the comet's orbit. Neither picture cares about drama. Both care about momentum, radiation pressure, and the gentle electric handshake between sunlight and molecules. As 3IATLAS cools, the gas-driven tail may thin. Dust liberated near perihelion can keep scattering sunlight a little longer, so photographers may catch a soft fan even as the spectra quiet down. Space.com points observers to late November and early December dawns with the caveat we always give: comets are temperamental. A crust can crack, A jet can switch. A thousandth of a newton here or there can reshape the coma in a night. That's why people keep watching. About the whispers, you may have heard talk of non-gravitational nudges, and what they might mean here is the steady version. Cometary jets do push. When gas vents preferentially from one side, it acts like a tiny thruster. Astronomers model those accelerations routinely for solar system comets, and they will test for them here too by checking whether a purely gravity-based path lines up with precise astrometry over weeks and months. If a small discrepancy shows up, the default explanation is outgassing, not alien engines. That's not dismissive, it's empirical. We've already caught the water echo, we've already seen a growing tail, we've already watched a sunward jet in pre-perihelion images. The ordinary comet explanation is not only sufficient, it is strongly supported by the data so far. As Darryl Seligman put it in a recent interview, perihelion is precisely when you get the most ices possible switching on at their threshold temperatures. The more ices that wake, the more likely you'll measure tiny natural pushes. Extraordinary claims would need evidence that cleanly refuses the cometary story. Right now, the cometary story explains what we see. We can also talk about what the next months will give science. Hubble's sharp eyes will refine the coma's structure whenever geometry cooperates. JWST will sniff for faint molecular fingerprints in the near-infrared. Mars' side data will continue to be teased for spectra, and a small armada Lucy near the Trojan swarms Psyche en route to its metallic target. Perhaps even JUICE on its looping journey will contribute opportunistic looks from novel angles, though data return schedules vary. Space.com's roundup notes that JUICE may need to cache data behind its antenna sunshield and downlink much later. A reminder that spacecraft are not general-purpose cameras, but mission tools we can occasionally borrow for comet duty. If that sounds unglamorous, consider the payoff composition at perihelion is a fingerprint of a faraway nursery. More carbon dioxide than typical elevated nickel lines, water far from the sun. Each clue constrains the temperature and chemistry where this body accreted billions of years ago. That is not clickbait. That is how you build a comparative planetology of other stars. For your imagination, and for any show that wants to feel like the Las Vegas sphere's wraparound sky, let the visuals grow from the truth. Begin with the ultraviolet OH ring, a faint sapphire veil pulsing from the coma, while tiny labels tick swift UVOT hydroxyl water's echo. Drop to a Mars horizon, a red crescent, a thin atmosphere, and above it a soft moving blur, marked 30 million kilometers. ExoMars, Cassis, the background stars streaked by the long exposure. Now swing into a stylized sun coronal loops breathing, and draw a narrow violet lance of a jet pointing sunward from the comet, the dust tail fanning away. Finally pull to a planetarium-wide map. Earth at dawn in late November. Place the comet low in the east, and let a gentle arc show its December minimum distance near 1.8 AU, comfortably far, photographically tender. Every element in that scene comes from a measurement or a mission brief. Nothing is invented for drama. If a little arithmetic helps anchor the wonder, keep these two sentences close. First sunlight fades, with the square of distance twice as far means a quarter. The energy per square meter, which slows the boil of ices and makes jets weaker. Second, the light we receive from the comet also fades with the square of our distance. To it twice as far means a quarter as bright in your camera, all else equal. Outbound, those two quarterings multiply, which is why the inbound leg often looks more dramatic, and why observers talk about catching a comet on the way in. No formulas, just the same rule twice, doing its quiet work. We should also name what this feels like from the human side. It's a discipline of attention. During the inbound months, survey telescopes flag a smear that doesn't belong. Coordinators put out a call. Professionals and amateurs swing their instruments into alignment. Spacecraft teams check their constraints, and if the geometry smiles, they sneak a look. The payoff is not a neon spectacle, but a catalogue entry with teeth, dates, distances, spectra dust, colours, jet directions, rotational light curves, and if we're lucky, a refined size. Hubble's August analysis favours a nucleus only a few kilometres across. That smallness is part of the charm. A thing you could walk around in a morning had you feet that could cling to coal-black vacuum ice is telling us about places we cannot yet name. So here is the near-term truth to carry into the sky. Pre-dawn November should give the first thin chances low in the east before sunrise, improving slowly into December as the comet draws farther from the sun in our line of sight, but also farther from us in space. So the brightness will be modest at best, no danger, no midnight swords of green through city clouds. Expect instead a faint breath of light in long exposures and the steady tick of spectra accumulating on servers. That may sound small, but it is large in the right way. We are watching water, carbon dioxide and dust from another stellar nursery turn to vapor under our sun and write their signatures into our detectors. We are watching Mars orbiters do side quests, Hubble, and if time allows, Webb peel at the glow, and a network of minds tune their instruments to the same quiet frequency. We are getting good at this, turning dim interstellar rumors into sentences we can read, and somewhere ahead of the Heliopause 3 IATLAS is already cooling toward the deep unlit reaches between stars, carrying away a little of our light and leaving us with the better part measurements we can keep. Picture the sun as a kiln cooling after a brief brilliant firing, and 3IA TLAS as the clay vessel you pull from the heat to listen for the tiny pings of its glaze. Those pings are the jets, the fading fluorescence of molecules, the delicate reshaping of a coma that only hours ago felt the strongest sunshine it will ever know in our sky. Perihelion, the closest swing by the sun, arrived at roughly 1 1/3 Earth. Sun distances hidden in the glare from our vantage point, but not from a fleet of space-based eyes that track the interstellar visitor right up to and through that turn. This is why the story currently belongs to spacecraft, and careful ephemerides the geometry put the comet behind the sun for Earth-bound telescopes at the very moment the physics promised, maximum activity, so the best observations came from heliophysics images and probes with a different angle on the scene. Space.com's observing brief laid that out, cleanly perihelion near October, the 30th in visibility from Earth, during conjunction and spacecraft ready to watch the outgassing crest. Universe Today stitched the same timeline to a set of unusual vantage points, including NOAA's coronagraph and ES. A mission looks showing how a modern solar system fleet can keep the thread when Earth must blink. What made the hidden turn especially valuable was chemistry you can actually name and picture. Over the summer before the glare, NASA's Neil Gehrels Swift Observatory stared in ultraviolet and saw the faint signature of hydroxyl OH, the daughter fragment of water that's been knocked apart by sunlight. You don't need math to feel why this matters. If you can hear OH glow around a dark, distant snowball, then water is leaving the surface and streaming into space. BBC Sky at Night Summary called it a major breakthrough, and the underlying analysis now sits in the literature, an ArcSiv preprint that quantifies the OH emission and infers a notable water production rate even at a heliocentric distance where ordinary comets are often still quiet. This isn't a rumour of water, it's a measured echo. So the interstellar recipes include our simplest solvent too. Because perihelion happened on the far side of the sun to us, another planet briefly got the better seat. In early October, Mars orbiting spacecraft pivoted for a long, low-light look. ESA reports that the ExoMars Trace Gas Orbiter and Mars Express pulled a faint, fuzzy glow out of the darkness from about 30 million kilometers away, the closest view any ESA hardware could manage. The point wasn't spectacle, it was continuity. While our telescopes were forced into daytime, Mars watched. That continuity becomes the backbone of the outbound campaign, a set of time-stamped frames that let modelers say how fast the coma swelled when it peaked, and how the grains of dust and puffs of gas changed colour as insolation sunlight per square metre began to drop again. Right around perihelion, other spacecraft caught something visually arresting, a narrow jet pointing roughly sunward, a behaviour both classic and instructive. When subsurface ices heat, they vent through cracks, the gas drags dust, and the outflow carves a bright lance within the coma. Because that jet aligns with changing spin and local terrain on the nucleus, its direction and brightness can flicker over hours. Because the sun's radiation and the solar wind sweep charge material outward, the iron tail pulls straight away from the sun, while dust forms a softer fan. Life Sciences Roundup emphasised how quickly the comet brightened as it swooped behind the sun in step, with expectations for a natural heat-driven engine. The physics is not exotic twice. The distance means a quarter the energy per square metre. Get closer by even a modest fraction, and the energy climbs sharply, waking more vents, which momentarily makes the whole thing look alive. We are watching sunlight do plumbing in vacuum. For those who love the craft of observing as much as the facts, there's a pleasing humility to what happens next. Earth will get the comet back in the pre-dawn by mid-November low in the east, and the view will slowly improve into December as the angle from the sun opens. But distance is destiny for brightness. The comet will never approach Earth closely. The minimum distance sits near 1.8 astronomical units, on the order of 170 million miles in mid-December. Earth Sky's guide is candid: you'll want at least an 8-inch telescope under dark skies. Naked eyes won't do. That is not a disappointment. It's a reminder that science often lives at the threshold of sight. Astrophotographers will stack many minutes of tracked exposure, a line on the comet's motion so stars smear to streaks and tease out a soft core and a fan of dust, maybe even the faint straight ion tail if the night is steady and the comet's processing is kind. The inbound months already gave us a gallery of honest pictures. AP News carried Neulab and Gemini South images, showing a lengthening tail and swelling coma as 3 IATLAS fell sunward. The aesthetic was subtle rather than sensational, exactly what you'd expect for an object that never gets especially close to either Earth or the Sunday. The same pieces also hammered home the safety and scale. No threat, no drive-by, just a distant dim traveller carrying chemistry older than our planet. Those frames now become before images to set against the after we'll collect on the outbound leg. If the dust population shifts, finer grains versus coarser, redder versus bluer scatter colour indices will nudge, and spectrographs will watch the standard bands fade at rates that tell you which volatiles run out fastest, at which depths. The comparison is the point. The slow change is the signal. Interstellar status is still the heart of the story. An open hyperbolic orbit means the comet isn't bound to the Sun. It is a visitor with momentum from some other nursery. Universes of speculation orbit that phrase visitor from elsewhere, but the measurements we have are emphatically cometary. We have OH from water in ultraviolet. We have coma growth with proximity. We have a sunward jet and a classic tail geometry. We have brightening that tracks the expected one over distance squared heating curve. Extraordinary claims would need data that refuses the straightforward comet explanation. Right now, the straightforward comet explanation fits cleanly. Astronomy's perihelion bulletin echoed that same theme, along with the OH result. Natural activity, expected chemistry, a dim but rich target for coordinated instruments. The wonder comes from how ordinary physics applied to an extraordinary origin yields a readable story. As outbound days accumulate, pay attention to 3 slow motions. First, the coma's breathing. As the nucleus rotates, jets switch on and off. As the sun angle shifts, previously shadowed areas may briefly take a turn at venting. As the heat budget shrinks, the gas-to-dust ratio ought to slide toward dust dominance, and the overall color can redden. Second, the tail's architecture. The straighter iron tail will stay leashed to the sun's direction. The dust fan will broaden and, under the right geometry, can produce an anti-tail illusion when we look along the dust sheet laid down in the orbital plane. Third, the light curve wiggles. Even a few kilometer nucleus can reveal its rotation if you watch carefully enough. Fresh vents opened by perihelion stress can subtly change the period or the amplitude. None of this will make front pages. All of it will enrich the comparative catalogue we're building across the first 3 interstellar visitors. You can turn those motions into visuals worthy of a wraparound screen without cheating a single fact. Open on a coal dark kernel wrapped in a thin sapphire veil labelled OH Waters Echo Swift UVOT. Let the veil pulse as if you were watching a long exposure condensed time. Cut to a Mars crescent and push the exposure until a soft blur lifts from the black. Pin a modest caption 30 million kilometers ExoMars TGO divided by Mars Express. Slide into the sun's glare with a stylized coronagraph mask and draw a slender violet lance of a jet pointing sunward, the dust fan fanning away. Finally lift to a planetarium map with the sun at center, Earth at dawn, and 3 IATLAS arcing outward, a thin line annotated closest to Earth, 1.8 AU in December, pre-dawn visibility from mid-November. Faint. It's not a stadium spectacle, it's chamber music. But chamber music at cosmic scale can still raise the hairs on your neck. If a little arithmetic steadies the imagination, place 2 simple sentences side by side. Sunlight weakens with the square of distance. Double the sun, comet distance, and each square meter receives a quarter of the energy, so ices sublimate less and jets weaken. The light we receive also weakens with the square of our distance to the comet. Double that distance and all else equal, the comet looks a quarter as bright. On the way out, both quarterings operate together. Less heat to drive the engine and the lantern farther away, which is why outbound comets tend to fade, even when the dust they shed near perihelion can keep scattering sunlight for a while. No equations needed. It's the campfire rule twice. There is also a patience here that feels like a new muscle memory in astronomy. Oumuamua startled us in 2017 with its comaless strangeness. Borisov in 2019 reassured us by acting like a textbook comet from the moment sunlight touched it. Atlas in 2025 is giving us water, fingerprints, jet physics in coronagraph, glare, and cooperative coverage from multiple worlds and platforms. Universe Today's perihelion note even flagged how missions not built for Comet's JUICE en route to Jupiter, NOAA's new coronagraph, could contribute vantage points when geometry lines up. This is what it looks like when a field matures from surprise to method rapid discovery, reporting coordinated follow-up across wavelengths and orbits, sober guidance to the public about visibility, and restrained delight when a spectrum whispers water. For you stepping out into a November dawn in Asia or Europe or the Americas, the practical picture is modest but real. Low in the east, under dark skies with a medium aperture telescope, you'll be hunting a soft-edged glow and perhaps a short fan-shaped tail. In images, filters centered on familiar comet bands can juice the contrast to common cyan from diatomic carbon if the gas is still rich, a broader, smoother tone if dust dominates, but the faintness will be the defining feature. Think of it as an exercise in attention, a way to put your eyes and your instruments into the same patient mode as the scientists who will keep collecting spectra colors and precise positions for weeks. We do not need spectacle for meaning. We need time, and we have that. And because this began with a kiln's fading heat, let it end with the pottery's quiet. Somewhere beyond Mars's orbit line of sight, a few kilometer nucleus is cooling breath by breath. The jets that made a narrow lance at perihelion will stutter and slow. The dust will drift in a widening sheet. The ultraviolet echo of water will drop into the noise as the sun's wattage per square meter dwindles. But every time Swift's detector counted OH photons, every time ExoMars and Mars Express pulled a gauzy smear from 30 million kilometers away, every time a coronagraph saw a bright spur form, as 3IATLAS slipped. Through the glare, our catalogue of other stars' small bodies learned to pronounce a new syllable. The comet will go, the measurements will stay. And the next time a doorway opens in the sky and a visitor drifts through, we'll already know how to listen. Imagine the comet as a cold, dark ember drifting out of a kiln, the glaze still pinging as it cools. 3IATLAS has tipped through perihelion and is now easing outward on an open interstellar path, a curve that never loops back. The timing and geometry are specific, not guesses. It skimmed closest to the Sun around October 29 to 30 at roughly 1.3 to 1.36 astronomical units, about 125 to 203 million kilometers hidden in the Sun's glare from Earth, but squarely in view for space-based watchers. That's why your backyard sky stayed quiet while mission teams kept working. The comet was literally behind the Sun for us. The fact that multiple professional ephemerides nail the same window and distance is the calm heartbeat underneath the headlines. What makes this visitor special is not just where it came from, but how faithfully it behaves under sunlight. Comets are heat engines. Warm sunlight wakes buried ices, those vapors stream off, gas pulls dust, a coma swells, tails bloom. Right when heating peaked near perihelion, when energy per square meter climbs steeply because sunlight weakens, with the square of distance, the interstellar snowball did exactly what physics predicts. It brightened, it sprouted, structured, jets, and it molded a classic gas-rich coma that coronagraphs and heliophysics images could see even while Earth had to blink. It's not spectacle for spectacle's sake. It's a tidy, testable chain. Distance falls, energy rises, ices cross thresholds, jets switch on, brightness ramps. We like that because it turns awe into a measurement you can repeat. And then there's the chemistry you can name in plain words. In ultraviolet light, NASA's Neil Gehrels Swift Observatory picked up the faint glow of hydroxyl OH around 3 IATLAS, which is what you get when sunlight splits water vapor and one of the fragments re-emits in ultraviolet. In other words, we heard water by hearing its daughter molecule. That single spectral line is a practical miracle. It turns the poetry interstellar snowball into a lab result that says yes, water is steaming off this object, even at distances where some solar system comets are still quiet. So, the most basic solvent in our biosphere is present in the ices of a body forged under another star. Geometry handed us an elegant workaround too. When Earth's line of sight was worst perihelion, tucked in daylight, Mars had the better angle. The European Space Agency pointed ExoMars, Trace Gas Orbiter and Mars Express outward during the first week of October, and coaxed a soft fuzzy glow from deep sky, about 30 million kilometers from those spacecraft. No fireworks, just continuity, a time-stamped series of frames that bridge the gap until Earth's dawns can take over again. It's a quiet illustration of how a planetary fleet doubles as a comet observatory when the orbits line up. What about size, closeness, and safety, the practical things people worry about? The orbit is hyperbolic, which is a mathematically precise way to say one-time visitor. It isn't bound to the Sun and won't return. The minimum distance to Earth sits near 1.8 astronomical units in December, on the order of 160 plus million miles. So there's no hazard here, only a faint, careful target for the patient and the prepared. If you translate that into brightness, expect something like magnitude 11 or fainter, at best, which is invisible to naked eyes and still challenging in small backyard telescopes. In a world that loves neon spectacles, this will feel like chamber music long, exposures, stacked images, and spectra gathered over many dawns. We'll take chamber music when it's this scientifically rich. Because this is the third interstellar small body we've met, comparison is inevitable and useful. Oumuamua never grew a visible coma and left us arguing about outgassing versus exotic geometry. 2. I Borisov behaved like a textbook comet. Now 3. IATLAS checks the classic comet boxes again, but with interstellar provenance stamped on the trajectory. Early reporting put a wide bracket on nucleus size from sub-kilometer to several kilometers as teams tried to peel coma light away from any direct nucleus signal. That range will tighten as outbound activity fades and models improve. Meanwhile, the compositional hints are already interesting. Observers discuss a gas-rich coma OH from water and even possible nickel line detections. Subtle, yes, but suggestive that the recipe of ices and trace metals in some other planetary nursery overlaps with ours while keeping its own accent. None of that requires headline-grabbing speculation. It requires spectra calibration and time. If you want to picture the physics cleanly, carry 2 sentences in your pocket. First, sunlight fades with the square of distance. That means if the comet is twice as far from the Sun, each square meter on its surface gets only a quarter of the energy it received before, so sublimation slows and jets weaken. Second, the light we receive from the comet also fades with the square of our distance to it. If we're twice as far from the comet, the light reaching our detectors is a quarter as bright, all else equal. Outbound, those 2 quarterings multiply less heating to drive activity, and the lantern farther away. No formulas, just the campfire rule applied twice. For observers, the timeline now shifts from the sun's glare to pre-dawn patience. As geometry improves late in November and into December, the comet will slide up from the eastern horizon before sunrise low and delicate. Astrophotographers will track the comet's motion and stack minutes of exposure so that the comet stays sharp while the background stars smear into gentle streaks. With luck and steady sky, you'll tease out a fan-shaped dust tail and perhaps a faint, straighter iron tail, pulled nearly directly away from the sun by the solar wind. The best views will come from dark sites and larger apertures. For the rest of us, the most honest thrills will arrive as processed images and calibrated spectra that translate into composition and grain size. It's not crowd-pleasing brightness, it's data-rich subtlety. Meanwhile, scientists will watch for 3 slow motions that tell real stories. One is the coma's breathing as rotation brings different vents into sunlight. Gas to dust ratios should shift as heating declines and colors can drift from the bluish tinge of gas-dominated light to a redder dust glow. Another is the tail architecture. A straighter ion tail that leashes itself to the sun's direction, and a broader dust fan that can, under the right perspective, create an anti-tail illusion, pointing sunward when we look along the sheet of dust sprinkled in the orbital plane. The third is the light curve's wobble, a subtle, bright, dim-bright rhythm that hints at the nucleus's spin and shape. If perihelion stress open new vents, spin rate or amplitude can change a little, the comet's own small thrusters nudging its dance. Here's the part that matters for story builders and sky artists who want visuals as breathtaking as a wraparound dome without cheating the science. Begin with the ultraviolet OH whisper that swift measured portray a dim sapphire veil haloing a charcoal kernel, and let that veil pulse with slow life, a visual metaphor for a spectral line counting photons. Then cut to a Mars crescent in a black field, and let a soft blur hover above the limb, captioned with a modest 30 million kilometers, to honor what ESA's orbiters accomplished while we were blinked out by daylight. Swing inward to a stylized sun with a coronagraph mask, and draw a narrow violet-tinged jet pointing sunward from the comet, while a broader dust fan leans away. Finally, zoom out to a planetarium map of the inner system and draw a thin dotted arc from perihelion past November's dawns to December's safest, by far minimum distance, near 1.8 astronomical units. Everything in that sequence is anchored to real measurements. Everything earns its drama. If you crave one more layer of international context, how the wider community is framing 3 IATLAS note, how soberly the major desks have handled it. Wire services emphasize the third ever status, the hyperbolic orbit, and early signs of an unusually lively gas-rich coma as the sun's heat came up. They underscored the large distance at closest Earth approach and the scientific opportunity over the public spectacle. Magazine briefs focused on perihelion timing and the fact that spacecraft, not backyard observers, would have the best seats during conjunction. They also flagged the intriguing hints of trace metals and compositional fingerprints that might read like the accent of another star's nursery. The tone is exactly what you'd hope: cautious, where samples are small, excited where spectra speak, and allergic to overpromising a sky show. We should acknowledge briefly that extraordinary claims always swirl around interstellar visitors. Some essays speculate about non-gravitational nudges as signs of exotica. But jets push comets, it's normal for outgassing to act like tiny thrusters, and astronomers routinely include such accelerations in comet orbits when the astrometry demands it. Given that we've already seen a swelling coma sunward jets in images, and the ultraviolet echo of water, the straightforward active natural comet on a hyperbolic path hypothesis fits the evidence snugly. Extraordinary alternatives would need clean, stubborn data that refuses the cometary story. So far, the cometary story keeps winning. We can hold wonder and restraint in the same hand. What finally does this teach us beyond a single object? It says that water shows up in the ice chests of other stars, that dust and gas interplay under sunlight the way they do here, that a planetary fleet can improvise mid-mission and extend our eyes when geometry goes against us, and that we are getting faster, calmer, and better at turning these brief interstellar appointments into catalogues of meaning. Oumuamua startled us. Borisov reassured us. Atlas is letting us practice. The cadence is becoming familiar. Survey, telescopes, flagger smear. The community rallies. Spacecraft pivot. Spectra arrive. The public gets a quietly accurate narrative in days, not months. It is in its own way a new kind of ordinary. An ordinary where a few kilometre relic from a nameless star system can cross our dawn and leave behind numbers that let us compare kitchens across the galaxy. So here is the picture to carry into your own pre-dawn: a dark kernel, a few kilometres across its vents, relaxing as sunlight dwindles to dust, fans sighing outward, and a faint ultraviolet whisper where water was briefly a gas. Low in the east it will be subtle, maybe invisible to your eye, but not to the stacked exposures and patient spectra that will keep arriving. We will listen as long as the signal lasts. And then, as always with interstellar things, it will go on. Exhale spent momentum intact, leaving us with the better part measurements. We can keep comparisons we can make, and the quiet thrill that our sky sometimes admits a traveller from. Another Sunday. Think of the comet now as a quiet ember drifting out of the kiln, its surface sighing as the heat falls away. 3IATLAS has taken its turn around the sun and is slipping outward on a path that never closes, an open hyperbola that marks it as a visitor from another nursery. The timing of that turn is not a guess. Multiple independent ephemerides converged on a late October perihelion at roughly 1 1/3 Earth. Sun distances about 200 million kilometres, when the comet sat almost directly behind the sun from Earth. That geometry robbed backyard observers of the show right when sunlight was strongest, but it favoured the instruments we've stationed elsewhere in the solar system, which took up the watch as 3IATLAS crested in activity. Space.com's perihelion brief stitched the numbers into a single comprehensible line, closest to the sun near October 29. Distance on the order of 1.3 AU, and pre-dawn reappearance for Earth observers a few weeks later as the comet slides out of the glare. The essential point lands with pleasant unanimity across sources. This was a close brush with our star by interstellar standards, but still a respectful distance by human ones. To see why the hidden turn mattered so much, follow the simplest physics. Sunlight weakens with the square of distance. Halve the Sun-comet separation, and each square metre of surface receives 4 times the power. Double it, and you're down to a quarter. Around perihelion, the heating ramp steeply cracks open, buried ices cross their sublimation thresholds, and the nucleus can briefly look alive as vents switch on, and jets lace the coma. That is exactly what observers expected, and exactly what the spacecraft saw as three IATLAS skim behind the Sun for us. The open curve orbit, the hyperbolic tag that flags a visitor, not a resident, was already clear from Discovery data. The perihelion behavior simply added the familiar cometary choreography, bright and vent fade. We like that because it turns a once-in-a-generation headline into repeatable, teachable cause and effect. The deepest thrill, though, was chemical and beautifully literal. Months before perihelion, while geometry was still kind to Earth, NASA's Neil Gehrels Swift Observatory stared in ultraviolet and picked up the faint glow of hydroxyl OH around 3 IATLAS. In plain terms, sunlight knocks water molecules apart. One daughter fragment, OH, re-emits in ultraviolet. Catch that glow, and you have indirectly but decisively heard water vapor escaping the surface. The team's analysis reported a bona fide water fingerprint at heliocentric distances, where many solar system comets are still dozing, implying either a surface rich in easily lofted icy grains or unusually efficient water activity for an interstellar nucleus. There's poetry in the phrase "a note from another world," but the measurement itself is prose counts of photons in a narrow band that only makes sense if water is present. So the simplest solvent in our biosphere is part of the ice chest of at least one other stellar nursery. Geometry gave us a second, quieter miracle. When Earth's line of sight was worse, perihelion tucked in the Sun's daylight, Mars enjoyed a better angle. The European Space Agency pivoted 2 orbiters outward, ExoMars, Trace Gas Orbiter, and Mars Express, coaxed a fuzzy moving glow from deep sky, roughly 30 million kilometers from their vantage point. No fireworks, just continuity across the gap we on Earth could not bridge. Those time-stamped frames now serve as the backbone of the outbound campaign, letting modelers say when the coma peaked, how fast it swelled and how color shifted as the gas-to-dust balance evolved while insulation fell. It is a small, elegant example of how a planetary fleet doubles as a comet observatory when orbits line up. Stepping back, it helps to anchor the how close, how bright, how safe questions with sober numbers. The object never threatened Earth. The closest approach sits near 1.8 astronomical units in mid-December, about 160 to 170 million miles, which is astronomically near enough for science and comfortably far for safety. That geometry also explains the modest brightness expectations. This was never going to be a naked eye spectacle. Space.com's guidance places peak apparent brightness around magnitude 11 or fainter, a realm for large backyard telescopes under dark skies, and more often for long exposure astrophotography and professional instruments. It is chamber music, not a stadium show, which is precisely why the data are so precious. A dim, clean interstellar sample slipping past a prepared audience of spectrographs and coronagraphs. We can be content with delicacy when the science is this good. Because this is only the 3rd interstellar small body we've met, comparison is irresistible and useful. Oumuamua in 2017 stayed maddeningly comaless. 2I divided by Borisov in 2019 looked like a textbook comet the moment sunlight touched it. 3 IATLA. ESSA's joined Borisov in the classic column, but with interstellar provenance stamped on its trajectory. Discovery coverage from Reuters set the stage cleanly. Atlas survey in Chile flagged the mover on July 1st. The hyperbolic orbit confirmed its unbound status. Early images showed a nascent coma and a likely larger nucleus than Borisov. As the inbound weeks ticked by, reports began to hint at compositional accents from gas-rich color trends to intriguing trace metal lines. Space.com's chemistry updates even flagged a surprising nickel detection, subtle and tentative, but suggestive that the dust grains and volatiles in this nucleus carry a recognizable yet distinct recipe from our local kitchen. In comparative planetology, those accents matter. They are how you tell whether disk temperatures, irradiation histories, and mixing differed in the nursery that made this snowball. Even the way the coma and tails behave outbound tells a layered story. The straighter ion tail leashes itself to the sun's direction because the solar wind and the interplanetary magnetic field pull charged molecules outward. The dust tail, in contrast, is a softer fan controlled by sunlight's radiation pressure and the grain's inertia. Under the right perspective, a sheet of dust laid down in the orbital plane can create an anti-tail that appears to point sunward, a geometry trick that often confuses first-time comet watchers and delights those who know what they're seeing. As 3IATLAS cools, the gas fades faster than the dust, so images may record a lingering fan, even as spectroscopists report a thinning of gas emission bands. That stagger is not drama. It's basic thermodynamics playing out on a cold, dark iceberg a few kilometers wide. The cadence gas first dust longer matches what perihelion physics predicts and what the spacecraft glimpsed near the crest. If you want one more anchor for your intuition, combine the two inverse square sentences and let them do their quiet work. First, the energy available to drive outgassing falls off as 1 over distance squared, so doubling Sun-Comet distance quarters the heating and quiets the jets. Second, the brightness you receive also falls as 1 over distance squared, so doubling your distance to the comet quarters its apparent light. On the outbound leg, those two fade-outs multiply less fuel burned, and the lantern farther away. That's why inbound comets so often look livelier, and why the finest outbound images come from patient stacks that track the comet's motion while the stars smear. No formulas needed, just the campfire rule twice. For observers planning real nights under real skies, the practical picture is modest but meaningful. As November deepens, the comet lifts from the sun's edge into the pre-dawn low in the east, slowly gaining separation from the glare, even as the physical distance from Earth increases. Expect astrophotographers to do the heavy lifting minutes-long tracked exposures aligned on the comet's motion, so the nucleus and inner coma stay crisp while the background stars stretch into threads. Narrowband filters centered on common gas emissions to coax contrast if the gas remains active. Careful color work to watch the coma slip from the bluer tint of gas-dominated light toward a redder dust-rich glow as the weeks pass. The images will be honest rather than theatrical, and that honesty is the point. Each stacked frame and measured spectrum becomes one more data bead on an interstellar string we have only just begun to thread. Behind the images, a set of slower technical questions will occupy professionals for months. How does the gas-to-dust ratio evolve as the nucleus cools? Do rotation light curves betray a lopsided shape or a contact binary, two lobes gently pressed together like we have seen among some solar system comets? Did perihelion stress open fresh vents, subtly changing the spin rate as natural thrusters of outgassing torque the body? Can we trim the broad range of nucleus size estimates by peeling coma light from any direct nucleus signal as the activity wanes? None of these are headline friendly, but all of them help fix 3IATLAS in a comparative catalogue alongside Borisov and whatever comes next. If the nickel line reports hold up, for example, they will sit next to Swift's OH detection in the accent marks that tell us what temperatures and mixing ratios prevailed when this object congealed around its parent star. We live for those accents. They turn a name into a biography. There is also the human cadence we've learned to trust since Oumuamua first taught us how quickly an interstellar visitor can appear and fade. Survey telescopes flag a mover. The community rallies. Spacecraft teams check their constraints, and when geometry smiles, they steal looks meant for other missions. ESA's Mars pair did that in early October. Other platforms will contribute opportunistically as downlink schedules and power budgets allow. Earthside public explainers have grown calmer and faster. Reuters for the discovery context, space. Com for the observing and chemistry cadence. EarthSky for the Skywatcher distances and dates. BBC Sky at night for the swift water fingerprint and the Mars side images. The pattern is pleasing cautious, where the sample is small, excited, where spectra sing and clear about what the sky will and will not give a casual eye. We are getting good at this, turning thin signals into shared understanding without over-promising a neon spectacle. If you build visuals from truth, as a wraparound dome would let them grow directly from the data. Start with Swift's ultraviolet OH whisper, a dim sapphire veil breathing around a charcoal kernel. Label it plainly as water's daughter line and let the veil pulse like a long exposure, summing photons over minutes. Cut to a Mars crescent and pull a soft blur from the black. A tiny caption notes approximately 30 million kilometers. ExoMars, TGO, divided by Mars Express, to honor the geometry that made Earth blink and Mars see. Drop into the sun's glare with a stylized coronagraph mask and sketch a narrow sunward jet inside a broader dust fan. An honest postcard of physics, gas, jets, radiation pressure, magnetic fields. Finally widen to a planetarium map and ghost in the comet's thin arc from perihelion toward a December minimum distance near 1.8 AU, annotated with the unromantic but reassuring no hazard. Every element in that sequence is earned. Every label comes from a measurement. And if you step out before dawn, and see nothing with your unaided eye, remember that seeing is a collaboration. Somewhere above the horizon, a few kilometre nucleus as dark as charcoal is loosening the last of its heat. Jets that speared bright near perihelion are stuttering now. Dust shed in the furnace is still scattering sunlight in a soft fan. The ultraviolet echo of water that Swift counted has dwindled with the sun's falling wattage per square metre. Yet the measurements are accumulating all the same spectra, with narrow lines that carry chemistry-like curves, with gentle wiggles that carry rotation frames from Mars that carried us across a gap in our view. The comet will go. The numbers will stay. And the next time an interstellar doorway opens in the morning sky, we will already know how to listen quietly, patiently, precisely for the way sunlight wakes the ices of another star and writes their story into ours. On the morning of December the 19th, 2025, the story isn't a sky show so much as a quiet geometric milestone. That's when 3IA TLAS is closest to Earth, closest still being about 1.8 astronomical units away, roughly 170 million miles, about 270 million kilometers. Think of it as a distant check-in from an interstellar traveler. It crosses the minimum distance point and keeps drifting outward on its unbound hyperbolic path. The date and distance aren't estimates pulled from thin air. They're the same figures you'll find in EarthSky's running brief and NASA's public page, both of which fold in current ephemerides. What you actually experience at that time is subtle. Before dawn, the comet is low and delicate, a telescopic target rather than something your eyes will catch. It will be faint around 11th to 12th magnitude because two inverse square laws are working against you after perihelion. October 29th to 30th at about 1.35 to 1.36 AU from the Sun, and the comet is receiving far less sunlight per square metre, so outgassing is easing, and at the same time your distance to it is near its maximum minimum, so the light you receive is diluted. The result is chamber music, not fireworks, long-tracked exposures from images, gentle fans of dust, teased out in stacks, maybe a whisper-thin ion tail pointing away from the Sunday. Scientifically though, December the 19th sits in a rich narrative arc. A few weeks earlier, perihelion unfolded behind the Sun from Earth's perspective, hence why ground-based observers missed the crest of activity while spacecraft watched space. .com's observing briefs pegged perihelion October the 30th at about 1.35 AU and emphasised the spacecraft will see it, you won't geometry. That geometry is exactly why the closest to Earth moment in December isn't a visual peak. The comet is both farther from us and cooling. By December the 19th, the chemistry we learned earlier in the season becomes the headline. Using NASA's Neil Gorell's Swift observatory teams, detected hydroxyl OH, the ultraviolet fingerprint of sunlight-split water, when the comet was still far from the Sun, implying a water-rich coma activated at unusually large distances. That was followed and echoed in public explainers because it's so clean you don't have to see water directly. You hear OH glow in UV, and that's enough to confirm water vapor. So even if the closest approach morning looks uneventful to the eye, the comet's water story is already written into the data. There's also the vantage point poetry when Earth couldn't see the perihelion turn. ESA's ExoMars TGO and Mars Express leaned out from Mars orbit and pulled a faint blur from deep sky, an interstellar comet caught from another world at roughly 30 million kilometers. Those frames bookend the season and give modelers continuity right through the gap in Earth's view. That's why as we hit December the 19th, the catalogues feel unusually complete for such a faint object. Multiple observatories, multiple orbits, one stitched together timeline. If you want the what to expect that morning version in one breath, a safe distant flyby in every sense. No hazard, no naked eye comet. The best odds are a pre-dawn telescopic whisper, a soft core, a modest dust fan in stacked images, while the science value remains high because of everything learned before this date. Perihelion activity, water detection, spacecraft coverage. After the 19th, the separation grows, activity keeps fading, and 3IA TLAS continues its long outbound slide, still carrying that now measured signature of water from another stellar nursery. For planning or curiosity, live trackers will reflect all of this, with a distance curve bottoming out around December the 19th and sky charts showing awkwardly low pre-dawn placement. They're handy for hour-by-hour rise divided by altitude checks if you're chasing the comet with a mount and a camera. Just keep expectations honest. December the 19th is a calendar waypoint, not a spectacle, meaningful because of the numbers, not because of the view,